So, hey everyone, welcome back to the video 5 of the Zig series. If you haven't subscribed to the channel yet, please make sure you subscribe and like the video as well to support my channel. In today's videos, we are going to cover struct, enums and switch basically. So the Zig gives you 3 tools to organize and represent your data. So we are going to also cover the optional type Zig safe replacement to the null pointer. So this is basically a content heavy video. Please bear through my voice. Moving to the next slide, a struct is a name collection of field and the foundation of data modeling in Zig. Before we move to the structs, let's go to the coding because I remember that last time when we were covering the memories and allocators video, last code was not working. Why it was not working is because we forgot the differ here. What this differ is doing is basically it is putting this check at the end of the function execution, and then when it checks for the end, obviously then it works correctly, so that it panics because there is a memory leak. And you can see that our program was getting stuck as well, and maybe that was also the cause of the memory leak. But let's move to our current video and structs. So how does a struct look like? So struct is like you are creating a point and a struct, and there are two variables called f32 and y float 32. Basically what these are basically the float variables. Now I'm not going to go too much into that how the definition looks like, because it's more or less in any programming language. We are trying to create an instance of the point variable with .x and .y equal to 4.0, and we can print it as well. Moving forward, fields can have default value defined here as well, like uint32 equal to 800, width is 800, and then the height is 800. A field with default value 800. So when you create a config for instance, you can define a default values. If any values are not given, then basically the 800 is automatically used. Then structs can have functions inside them. When a function takes a struct as its first parameter, it's become a method. You can call it with a dot notation or an instance. So this basically a function is area, and it is taking a rectangle into itself. So what it happens is that rectangle becomes the part of the struct here. This is what we were going to explain. Secondly, explicit return is always required, and it calculates the multiplication of width and the height, which is basically the definition of the area. Third method, which is also doing something similar, is called scale. A mutation method.self is a pointer to the rectangle, to the original file, and the pointer means a mutation is allowed. Without the pointer, changes to self would only reflect in the local copy. That means you will not get the changes. Now, self.width is basically a factor, so it modifies the width field through a pointer, and this changes the original rectangle, not the copy. So now we see that there are, in slide 4, we can see it's a common pattern. So this basically is a common pattern where the first line in the struct is used. So what we do is that you do const self @this. This is basically a built-in function that return types of the struct. It's called it inside the vec2. So what this represent in any other language is yourself. So when I call this, basically you are referring to yourself. That means in this case, it will be vec2. So this is example which you can see in which there is a vec2 or struct where there are two variables x and y. There is a method called length, and there is a method called add. I'm not going to spend much more time into this because I know conversations are boring. But as I told you, I can spend time on writing it, but I would like that this you try yourself, because this is common in any programming language. This is not something specific to Zig, so we can spend our time avoiding to write, but you can write it. Definitely pause there and write this for you. Now we go to enums. How do we use declare an enum? It's pretty simple. Const direction equal to enum, and then you define all the things. How do you use it? If someone wants to use a directory, use .north, right? And if you want to switch among them, you can use .north, .south, .east, and .width. Basically, these are all the enums, and then you can use a print statement to print it as well. Pretty straightforward. So this becomes really easy when you're using with Zig. Now with enums with the integer value. Enums can be backed by an integer type and can have an explicit value. That means OK can mean 200, not found can mean 404. So when you try to convert an enum from an integer, it is possible because now HTTP OK means 200. That means the value of code now is become 200. Here we know you have already seen the methods, so init from enum, or you can use the other method which is goes to the other direction, converts an integer into the matching enum variant. So this can fail if the integer does not match any variant. So basically if you try to pass 404 and it doesn't match any variant here, that means it can basically give you an error that you're already seeing. Now, next to the unions, and it also gives you already a warning. So let's first explain what unions are. A union is a type that can hold one of the several data types, but only one at a time. The problem with the bare union is that you cannot tell which field it is currently active, and accessing the wrong field is an undefined behavior, basically a potential crash. vFloat is undefined. We cannot know which field is active. So basically in there, we don't know which field is active because in v.value you are using integer, and if you use v.float, then it's a non-active field which can cause a problem. The solution which comes from this is called a tagged union. How do we see a tagged union? Is basically tagged union becomes really powerful when you add methods, and your methods, this is a Zig pattern. But first we need to see how the tagged union looks like. So here you can see an example of a tagged union in which now you can switch safely because you have all the three variables here, and now creates. So what it union does is that union enum basically creates a tagged union, generates like basically one variant per field. So instead of passing just union here, you're using enums here. So this is the difference between a bare union and a tagged union. Now in the switch case, you can easily switch between int, float and text, which is not possible in case of bare unions. Now tagged unions with methods. Tagged unions become really powerful when you add methods to it. This is a Zig pattern for polymorphism without classes or inheritance. So you can see a code in front of you, basically this is like a const shape union taking enum, which is make it a tagged union. We have a data type or float 64. We have a rectangle, which is a structure of width and height. And then you create a function called area, and it's a method because it's taking the shape itself, and it returns you with a switch case whether you are passing a circle or a rectangle. Right? Now, moving forward here. When you basically want to create a circle with like mat.py.r, which you are doing basically here, it will capture the radius and it computes the circle area, and each arm evaluates an area value to itself. And similarly, if you want to calculate a rectangle, you have to pass width and the height. So basically when you create this, you can pass anything, and then based on what shape you are sending it, it can create you a circle and it can also create you a rectangle. Now basically we have optional type. And the last topic, like this is the last topic for today. So Zig has no null pointer in C sense. You cannot accidentally have null. So where do you expect one? Basically you should create sometimes a null pointer, right? And this is what it gives you using a maybe. So what does this question mark represent? I equal to 32. If it's a value, it's I equal to 32. Now, the safe way to use optional is with a if and a capture. If value v, if the value is basically not null, execute the block v bound to the unwrapped value. If the value is null, basically execute the else. There can be a fallback is basically if you are not able to see here. So basically there can be a fallback with the or else. So you say like const result equal to maybe or else 0. So in case if it's a null value, you will get 0 or you will get the actual result. Yeah, this is for today's slides. So what we have covered in the video 5 is basically structs, groups that are related, groups basically which wraps a related field together. We have enums, fixed set of named variants. We saw union with an enum, which is a tag union, one active field at a time, tracked separately by automatically generating an enum. Use a switch with capture the pattern match and extract the value. Tag union can have methods, makes them Zig's way of doing a type-based dispatch without inheritance. Then we see the question mark type. The last thing which you can see in my slide here is an optional, a value that might be null. If we use v or else or dot question mark when you are certain if it's like it can handle the possibility of not null. In the next video, we go over slices, arrays, and pointer and how Zig made them basically about memory and collection. So see you in the next video. Have a nice time and bye bye.